Welcome back. In the previous session, we have seen convolution of two rectangular pulses of equal width. So in that, I said when convolution of two rectangular pulses occurs, the result is always a triangle. And in the triangle, we can find out the triangle easily. Just we have to see what is the lower limit, what is the upper limit. Once we know that, then we have to say what is the midpoint. That is the where we can get the peak value. And we already told you what is the rising edge and falling edge slope, which is equal. And what it is equal for? It is equal for the magnitudes multiplication. This is what we have seen. Let's take one question so that we can understand how easily we can do it. Suppose, example, I have taken a rectangular pulse which is existing between -1, +1, 0. So here let's say it is a 1 x of t. If it is convolved with a h of t, zero to h of t, what is the result we are going to get? Can you do it? So simply, let's see. If you observe carefully, the width of the rectangular pulse is 2 units. Here also the width of the rectangular pulse is 2 units. So I can say yes, it is a equal width rectangular pulses. Then the result is always a triangle. So if it is a triangle, can you tell me where it is existing from? So the lower limit is -1 plus 0, which is nothing but -1. -1 is the lower limit. The upper limit is 1 plus 2, which is nothing but the 3. Which is nothing but the 3. Next we have to see what is the midpoint between -1 and 3. Actually we have to say what is the distance between -1 and 3. So that is nothing but 4 units. If 4 units is the distance, midpoint must be 2 units from each corner. So I can say from -1 2 units means it is 1, or from 3 2 units means it is also 1. So I can say this is the peak value where it occurs. So we can directly write the triangle which looks like this. Now, what is the slope of rising edge? Which is nothing but 1 into 2, that is 2. Slope of falling edge, same but with a negative sign. So that is what the triangle. Can anybody tell me what is the peak value? So let's see. Slope 2 line, that means 1 unit increase in x-axis leads to 2 units increase in y-axis. But if I say -1 to 1, how many units we are increasing? Actually 2 units. So in y-axis we have to increase for 4 units. So that 4 by 2, which is nothing but slope 2. So I can say the peak value is nothing but 4. So this is what y of t. As simple as that. I hope you understood. So when two rectangular pulses of equal width get convolved, then the result is always a triangle. Okay, take it. Okay. See here. Convolution of dividing convolution of two rectangular pulses of unequal width. Unequal width. Two rectangular pulses of unequal width. Let's take one example. Zero, 1, let's say 2. This is x of t, let's say 3. Let's say this is x of t, whose width is nothing but 1 unit. If it is convolved with h of t, 0, 4. Now, observe carefully. These are two rectangular pulses. What is the width of this rectangular pulse? 1. The width of the rectangular pulse is 4 units. So I can say these are the rectangular pulses with unequal width. If they get convolved, what it is going to be? Let's take the usual method. Y of t is equal to x of t convolution with the h of t. Now, what is x of t in terms of u of t? You know how to write that. Because there is a jump at 0, 3 units, and there is a negative jump of 3 units at 1. So how we can write this? 3u of t minus 3u of t minus 1. So this is what the x of t. Now, if it get convolved with h of t, what is h of t? At 0, 2 units upward jump, so 2u of t. At 4, 2 units downward jump, u of t minus 4. If these two get convolved, then what will happen? Let's say. Because distributive property, I can go with 1 by 1 term. 3u of t, 2u of t, that is 6r of t. 3u of t convolution with minus 2u of t minus 4, that is minus 6r of t minus 4. Next, minus 3u of t minus 1, 2u of t, that is minus 6u of, r of t minus 1. Next, minus 3u of t minus 1 convolving with minus 2u of t minus 4. This is plus 6r of t minus 5. T minus 5. So write them in ascending order. 6r of t minus 6r of t minus 1 minus 6r of t minus 4 plus 6r of t minus 5. This is what y of t. We have to draw this. How it is going to look like. Let's see. Is equal to. Y of t. You tell me how we can draw this. First, we are having the corner points 0, 1, 4, 5. 0, 1, 4, 5. These are the corner points in ascending order. Let's see how we can draw this curve y of t. 6r of t. That means up to 0 we are having the slope is equal to 0. Up to 0 slope is equal to 0. From 0 its slope is becoming 6. So this is the slope 6 line. Slope is equal to 6 line. Next, at 1 how much slope is introduced to minus 6? Already slope is there 6. If I introduce minus 6 slope, then the slope will become 0. That means it is going to be horizontal line. So from 1 onwards it is going to be horizontal up to next corner point. What is the next corner point? 4. It's not looking like horizontal. Okay. At 4 this is slope is equal to 0. At 4 how much is the slope introduced again? Minus 6. So already 0 is there. So if I introduce minus 6, final slope will become minus 6. So it is going to be minus 6 slope line, which is decreasing line. Slope is equal to minus 6. Now it reaches the 5. At 5 it is introducing 6. So final slope will become 0. So this is what we are going to get, which is nothing but the trapezium. Can you tell me what is the maximum value for this? slope 6 line. That means for 1 unit increase in x-axis, there is a 6 units increase in the y-axis. So 1 unit we have increased. So how much has to be increased in the y-axis? 6 units. So that 6 by 1, which is nothing but slope is equal to 6. Okay. So this is what we got. So still we can say we don't have to do these calculations. Without doing these cumbersome calculations, by directly seeing these two waveforms, we can draw y of t waveform. How, sir? Simple. First, try to understand. Whenever two rectangular pulses of unequal width get convolved, the result is always trapezium. The result is always trapezium. That's clear. Once we understand it is a trapezium, so next what we have to do, we can find out what is the lower limit, upper limit. That is nothing but 0 plus 0, 1 plus 4, 5. So 0, 5 is the upper limits. So 0 is the lower limit, 5 is the upper limit. Okay, this is what we know. Next thing is, if you observe carefully, this is called as rising edge, this is called as falling edge. So rising edge having the slope is equal to 6, falling edge having the slope is equal to minus 6. I can say rising edge and falling edge having the equal slope but with opposite sign. And if you observe carefully, this slope is given by the magnitudes multiplication or amplitudes multiplication, we can say. Yes. So 3 into 2, that is nothing but the 6. So that point is also clear. But only one thing we have to remember. See, this is a rising edge. This is a falling edge. How much width it is occupying? So this rising edge, it presents for 1 unit. And here falling edge is also presents for 1 unit. How we can say this is 1 unit? So from what information is going to say, yes, this is going to be 1 unit. So actually, if you observe carefully, rising edge width, falling edge width are equal, and this is equal to the smaller width of the two rectangular pulses. That means out of x of t and h of t, whichever is having the smaller width, here it is nothing but x of t having 1 unit. So that 1 unit itself is nothing but the width of rising edge and width of falling edge. I hope you understood. So I am telling you again these points. Whenever two rectangular pulses of unequal width get convolved, the result is always trapezium. And once we know the trapezium, next what we have to do, we have to understand what is the width of rising edge, what is the width of falling edge. They are nothing but the width of smaller width. That means whichever is the smaller width we are having, that width we have to consider. Next point, rising edge and falling edge having the slope which are equal in magnitude but opposite in sign. And this slope is given by the multiplication of amplitudes of the two rectangular pulses. So this is what we have to remember. So I am writing these points, let's see, one by one. Result is always a trapezium. That is the first point. Next, width of rising edge is equal to width of falling edge. And this is equal to smaller width of the rectangular pulses. Smaller width of rectangular pulses. Smaller width of rectangular pulses. Next, third point. Slope of rising edge and falling edge are equal but opposite in sign. Are equal but opposite in sign. opposite in sign, and slope is given by product of amplitudes. These are the points what we have to remember. So remember, this is nothing but width is equal to 1 unit. Here also the width is nothing but 1 unit, and this width is equal to smaller width of the rectangular pulses 1 unit. Okay, take it. In the convolution, let's say time scaling property. Time scaling property. What is this property saying? That suppose x of t convolution with h of t, if it is equal to y of t, if it is equal to y of t, what if I do the time scaling for x of t, that means x of at, convolution with time scaling of h of t, that is h of at, what is the result it is going to give? So I hope you understood. If I do the time scaling for x of t as well as h of t both, then the result is always 1 by mod a y of at. So here output is also scaled, but here time scaling by a, but amplitude scaling by 1 by mod a. So this is very, very important. Okay, so don't ask me doubts like, sir, what if it is x of at convolution with h of t, or x of t convolution with h of at? So those formulas are not here, so they are not the generalized formulas. So this is the correct formula what we have to remember, and they don't have any standard results what we can say. So let's say if somebody is asking x of at convolution with h of t, so these convolutions we don't have the standard results. Standard results we don't know, but if I want to find out this value, yes, we can do it. We can do it, but we don't have the standard result for these kind of things. Okay, keep that in mind. So the standard result is only for x of at convolution with h of at, and the result is 1 by mod a y of at. Okay, so from this I can write one more property, which is a time reversal property. Time reversal property. What is time reversal property? So you can understand easily. Suppose in place of a, if I substitute minus 1, x of minus 1, h of minus 1 is equal to 1 by mod minus 1 is equal to 1 only, y of minus t. So I can simply write x of minus t convolution with h of minus t, which is y of minus t. Y of minus t. So that is another result, time reversal property. Okay, take it. From this property, time reversal property, we can write the symmetry properties also. What is symmetry property? Suppose if I take a even signal, convolution with even signal, then what is the result? It is not a multiplication, but still it is going to give you the same kind of results. The signal what we are going to get is a even signal. Let's take small proof. Only for this one I will give proof, and for remaining things I will directly say. Otherwise, if you want the proof, you can do it by yourself. Okay, let's see. Suppose a signal x of t is a even signal, convolution with h of et. Let's say this is also even signal, so which is nothing but y of t. I want to see this result. So if two signals which are even signals, then what is the result? That means what is the nature of y of t? Is it an even signal? Is it an odd signal? We have to see. Okay. For that, let's say we know time reversal property. I am just giving you the proof here. Time reversal property. What the time reversal property is saying that x minus t convolution with h minus t. Then the result is also y minus t. Time reversal property. From time reversal property, this is what it is going to be. Now you tell me what it is going to be. For an even signal, if I time reverse, will it make any difference? No. It is going to give you the same answer, x even part of t. Convolution with h t is equal to y of minus t. Now, we know this one is equal to y of t. This result is nothing but y of t. So, from here, I can write y of t is equal to y of minus t. What it is saying? If you take time reversal, you are getting the same signal. That means the result is nothing but even signal. So it is nothing but even. So I can say if two even signals are getting convolved, the result is also a even signal. That's what the meaning of it. And next, in the similar manner, I can say a odd signal convolution with another odd signal. The result is even signal. Next, an even signal convolution with an odd signal, then the result is odd signal. So these are the things what we have to remember. Take it. Suppose if you take a causal signal convolution with another causal signal, what is the result? It is always causal. Always causal. How we can say this? It is a causal, sir. Try to understand. What is the meaning of causal signal? That means the signal should not exist for negative values of time. So if the signal is not existing for negative values of time, that means it is present only for the positive values of time. So if the signal is present only for positive values of time, if you understand what is the lower limit of the signal, always positive. Then if you take another causal signal, that is also having the lower limit, which is always positive. So if you convolute these two signals, then the resultant signal is also having the lower limit, which is nothing but positive plus positive, which is nothing but a positive value. I hope you understood what I am trying to say. So if you take a causal signal, the signal is only present for the positive values of time. That means definitely the lower limit is always a positive value. Whenever the lower limit is always positive value, if you add two positive values, you are going to get always a positive value. So for the resultant signal is also the lower limit is positive value. That means the signal is present for entirely in the positive values of time. Then I can say the signal again, it is going to be causal signal. Okay. In the similar way, suppose if you take anti-causal convolution with anti-causal, then the result is again anti-causal. How, sir? How we can say this? Let's try to understand. Same kind of explanation I can give. Suppose if you take anti-causal signal, that means the signal is existing only for negative values of time. If the signal is existing only for negative values of time, so I can say what is the upper limit of the signal is always a negative value. Next, if you take another anti-causal signal, for that also upper limit is always a negative value. So if upper limit is a negative value for both of them, what is the resultant signal having the upper limit? Minus plus minus, which is nothing but again a negative value. So I hope you understood. Two negative values sum is again a negative value. So upper limit is negative value means the signal is entirely existing in the negative portion. So it is a anti-causal signal. Next, suppose if you take a causal signal convolution with a anti-causal signal, then what is the result? See, here so many people will say a causal anti-causal signals are getting convolved. Then so many people think that yes, we may get a non-causal signal or causal signal or anti-causal signal like that. First of all, there is no such rule. So it is entirely depending on the limits. How, sir? First try to see, you can understand easily. I will take a simple examples. If a signal is existing only between let's say 1 and 2, so it is a causal signal because which is existing only for positive values of time. If it is getting convolved with another signal which is existing only for negative values of time, let's say -9, -8, then what is the result? I told you two rectangular pulses of equal width get convolved, we are going to get a triangle. What is the lower limit of triangle? 1 -9 -8, 2 -8, which is nothing but -6. So the resultant is existing between -8, -6. So I can get a causal, anti-causal get convolved. In this case, it is anti-causal. In the same way, if I take a causal signal in this manner, let's say 8, 9. So it is a causal signal now. Convolution with let's say anti-causal signal, which is like this, -2, -1. The resultant now existing between 6 and 8. So this is nothing but causal. So there are situations this will become non-causal also. So can I simply say a causal signal convolved with anti-causal signal, we don't have any specified result. It is entirely depending on the limits of the signals. So where the signals are existing, that is what it is going to determine what is the resultant signal. So I can simply write depending on limits. Depending on limits. Depending on limits. Okay, take it. I am writing the question. Y of t is equal to x of t convolution with h of t. X of t convolution with h of t. G of t is equal to x of 3t convolution with h of 3t. H of 3t. If g of t is equal to a y of bt, a y of bt, then a and b are, then a and b are, options are given like this, 3, 3, option B, 1 by 3, 3, option C, 3, 1 by 3, option D, 1 by 3, 1 by 3. So here, if you observe carefully, which one is the correct answer? So option B is correct here. Why, sir? Simply, let's see. If x of t convolution with h of t is equal to y of t, then time scaling property, what it is saying, x of 3t convolution with h of 3t is nothing but 1 by mod 3, which is nothing but 1 by 3 y of 3t. So this is what they have given. So g of t is equal to a, capital A value is equal to 1 by 3. So this is 1. So and capital B is equal to 3. So I can say this is the option B is correct. Question number 33. Next. Question number 34. What it is saying? Simply x of minus t convolution with a delta minus t minus t naught. What is this value is equal to? Options: x of t minus t naught, option B, x of minus t, option C, x of minus t plus t naught. Option D, x of minus t minus t naught. Which is the correct answer? If x of minus t is convolving with delta minus t naught. Let's check it out. So whenever multiple operations are given, so it is not only true here, it is true everywhere. Even if it is a continuous time Fourier series or continuous time Fourier transform, Laplace Z-Transform, everywhere. Remember only one thing, if multiple operations are given, then we have to start from what we know. That means whatever you know, you have to start from that point. So that is what the clue here. Okay, let's see. We know that, what we know, x of t convolved with delta t. What is the result? I told you, if any signal is convolved with delta t, it is going to result the same signal x of t. Same signal x of t. This is what we know. Next, if x of t convolved with delta t minus t naught, then we have to introduce the shift in the output also. That is nothing but x of t minus t naught. Up to this point it is okay. Now if I apply the time reversal property, that means if I replace t with minus t in both the signals, minus t here, delta minus t minus t naught. In both the signals, if I replace t with minus t, then in the output also we have to replace t with minus t. That's what the property of time reversal. What is time reversal property saying that? You might remember, if x of minus t convolved with h of minus t, result is y of minus t. So from that property, yes, this is also x of minus t minus t naught minus t naught. So from where we have written property, since x of minus t convolution with h of minus t is equal to y of minus t. So from this property we have written this one. So finally the option is D. Option D is correct. Take identification of LTI system from impulse response. Identification of LTI system from impulse response. Impulse response. So this is very, very important. Actually, suppose if input output relation is given, then if you want to say the system is static, you can say it. So what we have to observe? The present output must depend on the present input. Then we can say the system is static. If it is not depending, if it is also depending on some other values of input, then we can say it is a dynamic. So this is the thing what we can say. Next, a system is causal or non-causal. We can say the present output should not depend on the future input. Then we can say the system is causal, otherwise non-causal. So these kind of things we can directly say from the input output relation. What if they have given h of t, that means impulse response is given. From that impulse response we have to identify the system, whether it is a static or not, whether it is a what we can say causal or not, or we can say stable or not, invertible or not. These kind of things we have to see. So for that we have to say what is the conditions on h of t or h of n. So if it is a continuous time case, h of t condition, or if it is a discrete time case, we have to see the h of n conditions. So these things we have to observe. So let's say one by one. First, I will go with a static LTI system. Static LTI system. So if an LTI system is static, what is the condition on h of t? Static LTI system. So that means if the system, LTI system, is a static system, then what is the condition on h of t or h of n? So how they have to behave so that it is going to be the static system. That's what we have to see now. So let's see. First I will go with the discrete time case, and from the analogy we can say this is the same case for the continuous time. Okay. So first let's go for discrete time. In the discrete time, y of n is equal to, let's go for the different color. Y of n is equal to x of n convolution with h of n. I am not changing the h of n, I am changing only the x of n. So I can get summation k is equal to minus infinity to infinity h of k x of n minus k. So this is what we are going to get. Let's expand this summation. If I expand this summation, k value is changing from minus infinity to plus infinity. So if k value is changing from minus infinity, that means and so on. If k value is equal to minus 2, then it is going to be h of minus 2 x of n plus 2. If k value is equal to minus 2, this is the term what we are going to get. If k value is equal to minus 1 plus h of minus 1 x of n plus 1. If k value is equal to 0, then it is h of 0 plus, h of 0 x of n plus h of 1 x of n minus 1 plus h of 2 x of n minus 2 and so on, plus and so on. So these are the summation. Okay. Now observe carefully. This is what the y of n. Y of n looks like this if I expand the summation. If you take y of n, in this y of n, observe carefully, we are having the terms of x. Here it is x of n plus 2, x of n plus 1, x of n minus 1, x of n minus 2, like that it will go. If you observe carefully, and so on, x of n plus 2. For y of n, x of n plus 2, what kind of input it is? Is it present? Is it past? Is it future? So definitely it is a future input. And this is also future input. Here it is present input, past. So I can simply say these terms, up to these terms, everything is future inputs. Future inputs. Next, x of n, which is nothing but present input. And these x of n minus 1, x of n minus 2, these are all are past inputs. So this is what we got. Now coming to the condition what we are trying for, static LTI system. So from the definition of static LTI system, y of n should depend only on x of n. So this is what the condition we have to get. So that means y of n has to depend only on x of n. That means these terms has to be 0 and these terms has to be 0. That means future input terms and past input terms has to be 0. So that y of n is depending only on x of n. Clear? So I can say for static LTI system, y of n must depend only on x of n. That's what has to happen. Now, if it is depending only on x of n, definitely this term has to be 0. That means, can I say h of minus 1 has to be 0, h of minus 2 has to be 0, and so on has to be 0. H of 1 has to be 0, h of 2 has to be 0. Only thing, this value h of 0 should not be 0. And remaining values all has to be 0. Then we can say, then h of minus 1 is equal to h of minus 2 is equal to, and so on, these values, and h of 1, h of 2, and these values also has to be 0. That means h of 0 should not be 0. So only h of 0 exists and remaining values has to be 0. Can I simply say, suppose if I take h of n, so this value is not equal to 0 for n is equal to 0, and this value is equal to 0 for n is not equal to 0. That's what the meaning of it. If n is equal to 0, only it is existing. So which kind of signal exists only at n is equal to 0? That is nothing but the impulse function. So from this we can conclude that h of n must be in the form of some k delta n. From this we can say this is the conclusion what we can say, k delta n. In the similar manner, if I try to find out for continuous time case, there also h of t is equal to k delta t. So if you don't believe it, let me prove it. Suppose for a continuous time case, if the system having h of t is equal to k delta t. For this, if input is x of t, what is y of t? Which is x of t convolution with k delta t, which is kx of t. So y of t is equal to kx of t. That means present output is depending only on present input. For y of t, x of t is nothing but the present input. So the system becomes static. So this is the input-output relation, and this is the impulse response. In the similar manner, for a discrete time case also, if I take h of n is equal to k delta n, if x of n is the input, then y of n is equal to x of n convolution with k delta n, then it is kx of n. Here also y of n is depending only on x of n. The system becomes static. Okay.